Ever wonder how a computer could see a person's posture in a photo and reconstruct it in 3D? It's not just about recognizing a pose. It's about understanding the geometry, the angles, the subtle shifts that make a yoga stretch different from a casual slump. That's where Pose-RFT steps in, a groundbreaking AI framework that's redefining how machines interpret human movement. Let's dive into how it works and why this could be a game changer for computer vision. So why is 3D pose estimation such a challenge? Think of a photo as a 2D snapshot of a 3D world. Our brains automatically infer depth, perspective, and spatial relationships. But for a computer, that's like trying to solve a jigsaw puzzle with half the pieces missing. Is the person leaning forward, twisting their torso, balancing on one leg? Traditional models struggle because they rely on supervised learning. Essentially, they memorize patterns from labeled datasets. It's like teaching a robot to cook by showing it recipes. It can replicate simple dishes, but creativity, ambiguity, that's where it falls apart. Enter Pose-RFT, a framework that doesn't just mimic human behavior, it learns like a human. Instead of relying on pre-labeled data, it uses reinforcement learning, a method where the AI experiments, receives feedback, and iteratively improves. Imagine training a robot to walk. It stumbles, gets a negative reward, adjusts its gait, and tries again. Pose-RFT applies this principle to 3D poses, letting the model explore possibilities and refine its output through trial and error. Here's where it gets really interesting. Pose-RFT employs a hybrid action space, blending textual descriptions with numerical pose data. This isn't just about generating a 3D skeleton. It's about creating a dialogue between language and geometry. For example, if you input the text, "The person is balancing on one leg," the model doesn't just output joint angles. It also generates a descriptive text summary. This dual output system is guided by custom rewards that ensure the generated pose aligns with the textual prompt. It's like a painter who gets points for both the color palette text and the brushstrokes pose. The goal is harmony, not just accuracy. To make this work, researchers developed HyGRPO, a novel algorithm that acts as a referee for the AI's guesses. Unlike traditional methods that pick a single best pose, HyGRPO evaluates multiple possibilities, normalizes their scores, and teaches the model to prioritize outputs that are both semantically and spatially coherent. For instance, if the text says airplane pose, HyGRPO ensures the AI avoids configurations where the arms are crossed or the legs are rigid, because those don't match the intended movement. This feedback loop allows the model to learn nuanced relationships between language and physicality, paving the way for more realistic and context-aware 3D reconstructions. Pose-RFT isn't just another AI model, it's a paradigm shift. By merging reinforcement learning with hybrid outputs and custom reward systems, it bridges the gap between abstract language and concrete physicality. Whether it's improving virtual avatars, enhancing motion capture, or advancing robotics, this approach opens doors to applications we're only beginning to imagine. Stay curious and keep exploring the frontier of AI, because the next breakthrough is just a few lines of code away.